The focus of this next lesson is on operations that we can perform on sets. So there are 4 things that we want to look at: the intersection, the union, and the complement, as well as disjoint sets. So put the video on pause, take a moment to copy down those definitions, and we'll look at some examples here in about 3 seconds. Okay, so the intersection of 2 sets represents the elements in common between 2 sets. So to be able to talk about this, let's define some things here, okay? So let's say that we have a universal set that is going to be 1, 2, 3, 4, 5, whoops, my commas aren't coming through, 6. And let's make set A equal to 1, 2, 3. Let's make set B equal to 4, 5. And let's make set C equal to 2, 4, 6. Okay. So we'll use those sets to look at these examples here. So, intersection. If I wanted to know the intersection between 2 sets, I might ask you a question like this. What is A intersect C? And so the answer is going to be another set. So if I look at A and I look at C and I figure out what they have in common, the only element that is in both A and C is the number 2. So that is a set containing only one element, but that is the set that represents the intersection between A and C. Okay, I could say the intersection between B and C. B intersect C, and the only thing that B and C have in common is 4. Now, both of these examples have one element in common, but you could have more than one. You could have none, which we'll see in a second. Union creates a new set that has both elements from one set or the other set. So what it essentially does is it combines the elements between sets. So for example, if I wanted to do A union C, I'm going to build a new set for every element that is in either A or C. So for example, 1 is in A but not C, but that's okay because it's or. So I need a 1, I need a 2, 2 is in both, 3 is in A, 4 is in C, and then the only other one is 6, which is also in C. So I have taken A and C and combined them together. Notice our elements are still in order, and we've not repeated. Like 2 is in both of them. I only need it to be an element in my union set one time. I don't need to repeat it. So it doesn't say 1, 2, 2, 3, 3, 4, 6. We just write it down one time. Okay. Now, the complement. I'm just looking at A in this case. The complement of a set would be the elements of the universal set that are not in the set that you are looking at. The symbol for complement is this little apostrophe after the set. So if A, in this case, is 1, 2, 3, and our universal set is 1, 2, 3, 4, 5, 6, then A complement would have to be 4, 5, 6. Because those 3 elements are in the universal set, but not in A. B is 4, 5. B complement would be 1, 2, 3, 6. Those are all the things in universal set that are not in set B. Okay. Now, if your 2 sets have no elements in common, that would mean that their intersection is the empty set, the null set, because there are no things in common. Those are called disjoint sets. So for example, A and B are disjoint sets because A is 1, 2, 3, B is 4, 5. They have nothing in common. Okay? So Let's move down and look at a couple of examples. I would like for you to put the video on pause and go ahead and try to answer these questions yourself. Union is the one that looks like a U, intersection is the one that is upside down. So take a moment to answer these. Put the video on pause because I'm going to reveal the answers in about 3 seconds. All right, here are the answers. Do make sure that you have those set brackets around the outside. On a quiz or a test, if you simply list numbers, that's just a list. In order to make it a set, you have to put the braces around each side, the little squiggly bits. So make sure that you have those, and if you don't, add them in on your notes because that must be a part of your answer. All right, moving on. For number 8, I want you to go ahead and again, put the video on pause. We're now talking about complements. So for example, a complement is going to be everything that is in U that is not in A. So pause a moment and see what you got. Answers coming your way in 3 seconds. All right, here are your answers. So in set A, we have 1, 3, 5, 7. So the only things that are not in A from the universal set are 2, 4, and 6. Again, make sure you have set notation here. B complement would be the set containing 1, 2, 5, and 7. Now C and D are a little bit interesting. We want the complement of the null set. Well, the null set is empty. So the complement of the null set has to be everything that is in the universal set. So you can just call it U because it's been named that way. Conversely, D wants to know the complement of U. So that's saying what is in the universal set, or I should say what is not in the universal set. Well, the only thing not in the universal set is the empty set because U contains everything. So that's kind of how the complement works that way. So those are your operations on sets.